Let's look at a couple examples of using law of sines when we have the side-side angle case. With these two examples, we'll look at how do we know if we have no solution or if we have one solution. Okay. So for the first one, we want to solve the triangle where we're given angle A is 40 degrees, side B is 15, and side A is 6. Okay, so again, don't get attached to the letters or even the positions you draw them in the triangle, because again, the triangles can twist and turn and flip. We don't have to have A, B, C's. We could have alpha, beta, gamma, but um, just just to kind of illustrate the point, we'll use A, B, C here. Um, so let's first draw a triangle. Again, my typical triangle is horizontal bottom side, and then two slanted sides going upwards to meet kind of up in the middle. I'll usually put the known angle in the bottom left corner. So in this case, we're given angle A, and then we know that's 40 degrees. The side opposite angle A is side A, and I know that has a length of 6. And then I know that the side B is 15. So just to make this match, I could easily put the 15 on the bottom. It doesn't really matter where it goes. But just to try and make this example sort of fit the illustrations we looked at before, I'm going to put B next to, it has to be next to angle A, but I'm going to put it on the top left side. So angle A in the bottom left corner is 40 degrees. Side A opposite that is 6, and side B on the top left is 15. All right. So just looking at the information we have, again, we have an angle and two sides, and the angle that we're given is not between the two sides. And so, again, just looking at that real quick, that does verify that we are looking at side-side angle. Okay, so we have to deal with how many solutions and triangles and stuff like that. We could then look at the length of the two sides. Okay, side A, the opposite side 6, is less than 15. Okay, so if it was the other way around, if side A was actually longer than 15, then we'd have one solution and we could go ahead and solve it and be done. Okay, but because that opposite side A is shorter than the adjacent side B, it's possible we could have no solutions, one solution, or two solutions. So we need to actually figure that out. And the other piece of information we needed to look at to do that was to look at the height of the triangle. And again, this height is measured between the unknown angle and the unknown side that's opposite it. So the angle at the top has to be, in this case, has to be angle C. So you always want to draw that height out of the angle between the two sides that you're given. And it should be perpendicular to the bottom side. So let's see down here. And we want to find the length of that, which we just call h because that's the height. And again, looking at our picture here, the left half of that triangle is now a right triangle. So let me draw that again down here. So we have a right triangle, angle A, the acute angle in the bottom is 40 degrees. We have a 90-degree angle in the bottom right corner. The side opposite angle A is H. The side opposite the 90 degrees is 15. That's our hypotenuse. Okay, so because that's our hypotenuse, we could do the sine of 40 degrees has to equal the opposite over the hypotenuse. So sine of 40 degrees equals h over 15. To solve that for h, we multiply the 15 to the other side. So we have 15 sine of 40 degrees is equal to h. And so again, that's just something that we can compute using technology. And so if we can compute that, 15 times the sine of 40 degrees is going to be roughly 9.64. Okay, so what we should observe then is that this 9.64, the height of the triangle, is actually greater than the opposite length of 6. Okay, so that means the 6 is too short. That means it will never touch. It will. That was that illustration we had where we could swing the opposite side back and forth, but it was too short. So in this case, there is no solution. Okay. All right. Let's look at a second triangle. This time we have angle A again. We'll say angle A is 50 degrees. Side A is 75, and side B is 60. And again, I'll draw my typical triangle here, horizontal side, and then our two slanted sides extending upwards to meet somewhere in the middle. I put the known angle in the bottom left corner. You don't have to. I just do this to match the illustrations that I had earlier. So angle A is 50 degrees in the bottom left, which makes side A equal to 75. Side B has to be adjacent to angle A. I could put it at the bottom if I want, but again, to match the illustrations I've used, I'm going to put side B to the top left here, and so my 60 is going to go there. So that means angle B is the bottom right, and angle C is the top angle, and side C is the bottom. Okay. So again, looking at the information we have an angle and two sides. The angle is not between the two sides, so that's side angle. Okay. Now, to figure out the situation that we're dealing with in this side angle case, again, let's start by comparing the two sides that we are actually given. We know that 75 is greater than 60. So the opposite side is longer than the adjacent side. So A is longer than B. And this was a case where we would only have one solution. Okay, so thankfully we only have to solve this triangle once. We don't have to do it twice. And solving it is just like we did in the previous example with the angle side angle. Okay, so we're going to start. We can look at our proportions. So sine of A over A has to equal the sine of B over side B, and that has to equal the sine of angle C over side C. And we can go ahead and plug in the values we already have. So I know angle A is 50 degrees, and I know side A is 75. So I already had the A fraction, sine A of 50 degrees over 75. And then for the B fraction, I know that the length B is 60. So I have one value in the B fraction and one unknown. I know nothing in the C fraction. Okay, so the only thing we can do is find angle B. So let's go ahead and do that. We'll take our proportion. If we cross multiply, so again, our proportion is sine of 50 degrees over 75 has to equal the sine of B over 60. Okay, so it's this proportion that we're working with here. So cross multiply, that is going to give me 75 sine of angle B is equal to 60 times the sine of 50 degrees. We divide the 75 over, so I have the sine of B is equal to 60 sine of 50 degrees over 75. But I want to find B, not the sine of B. So how do we get rid of that sine? We have to do an inverse. So I'm going to basically think of it as like taking the inverse of both sides of the equations. And on the left side, when you take the inverse sine of sine, they cancel. That was that cancellation property that we looked at. So B is going to equal the inverse sine of 60 times the sine of 50 degrees over 75. And again, that's something that we're going to go to our technology to use. So the inverse sine of 60 times the sine of 50 degrees over 75 gives us an angle of B of 37.79 degrees. Okay, so we now know angle B. We already had angle A, we now have angle B. So to find angle C, again, we can just use the fact that A plus B plus C has to be 180 degrees. And that means C is going to be 180 minus 50 minus the angle we just found, so minus 37.79. So that means C is going to be 92.21 degrees. So we now have all three angles, and we have one of the known values for the C fraction. So we can now go ahead and figure out side C. Let's use the A fraction with the C fraction. I'm going to use A because those were both given values. So I know the sine of 50 degrees over 75 is going to equal the sine of 92.21 degrees over side C. If we cross multiply, we'll have C times the sine of 50 degrees is equal to 75 times the sine of 92.21 degrees. So C is going to be 75 times the sine of 92.21 degrees over the sine of 50 degrees. And we can compute that on our calculator. And we should get that C is equal to 97.83 if I type that in right. Now, one thing just to kind of check ourselves quickly, again, this is not going to tell us for sure that we have the right answer, but it can hopefully give us some peace of mind. Remember that the law of sine gave a relationship, a proportionality between the measures of the angle and the lengths of the side. So the longest side should correspond to the greatest angle, and the shortest side should go with the smallest angle. So if I look in the example that we have here, the smallest angle I have is angle B. It was 37.79 degrees, and the side B was 60, which is the shortest side. It's 60. Side A was 75, and side C was 97. Okay. If we look at the largest angle, that would be angle C at 92.21 degrees. Then we should have side C being the longest side, which it is. So we can see that the shortest side goes with the smallest angle, and then the largest angle goes with the longest side. Again, that's not 100% guarantee that we're correct in our values, but it should give us a little bit of peace of mind that we're in the right direction. Okay.